out a series of examples that require us to analyze a given arithmetic sequence, maybe to find some missing terms and whatnot. So here we have a question that says, what is the 100th term of the arithmetic sequence that begins, first term being 6, the second term being 11? Since we know that's an arithmetic sequence, that is enough for us to know the pattern. For the sequence to be an arithmetic sequence, it must have a common difference, and I can look and see the difference between those two terms is 5. So I know my common difference, I know my starting point, so I could go ahead and write an explicit formula like I've done in another example for this sequence. I could start off and say a sub n is equal to the first term plus n minus 1 times that common difference, which I just said was 5. Going ahead and simplifying this, I have 6 plus distributing the 5 in makes 5n minus 5, and combining like terms, I get a sub n is equal to 5n plus 1. So there is my explicit formula for the nth term of this arithmetic sequence. Now the thing wants me to go ahead and find the 100th term of that sequence. I can just plug 100 in for n. So I have a sub 100 is equal to 5 times 100 plus 1, which is equal to 500 plus 1, which is 501. So the 100th term of this arithmetic sequence would be 501. Let's take a look at this example that wants us just to find a missing term between two known terms of an arithmetic sequence. If that's the case, if you know terms on either side of the term that you're looking for, and this is an arithmetic sequence, you know that that difference has to be common throughout. This is just simply an average question, finding the mean of these two numbers, the arithmetic mean of these two numbers. So you just can add up those two numbers right there. 4 and negative 6 makes negative 2, and divide by 2. That's how you find an arithmetic mean. You add them up and you divide by how many there were. So I'm just adding up these two neighboring numbers. 4 and negative 6 makes negative 2. Negative 2 divided by 2 is negative 1, and that should be the missing term in the sequence. You can look and see that the common difference here appears to be negative 5. To get from 4 to negative 1, it went down 5, and then it went down 5 again, and then it went down 5 again. So you can see that common difference being represented in there. So there's just how you can take advantage of the arithmetic mean to find a missing term if you know the terms on the either side. Here we have an example that wants us to find the missing terms in this given arithmetic sequence. I have the first term being 100. I have two missing terms in a row, followed by the fourth term being 82. So I can't just go ahead and, I don't have the one missing number between two known numbers, so I can't use the arithmetic mean by just adding them up and dividing by 2 to find that term in between. But what I can do is I can figure out the difference between these numbers that I know, since I have a couple missing ones in between. So the difference between 100 and 82, I'm going to go ahead and find that by taking the second one that I know, the 82, and subtracting 100 from that, and I would get negative 18. So to get from 100 to 82, this has to decrease by 18. Now, how many times does it have to decrease to get there? Well, I have to go from 100, I have to decrease once to get to some unknown number. I have to decrease again to get to some unknown number, that's twice. And finally, I would have to decrease a third time to make it to 82. So what I can do is I can take this total amount that I need to decrease of 18, I can divide it by 1, 2, 3, the number of times I would have to decrease to get all the way to 82, and get negative 6. And I can see that the common difference here is negative 6. Now that I know the common difference is negative 6, I can pretty quickly just go ahead and fill in these numbers. If I went from 100 and I went down 6, I would be at 94. And then if I went down 6 more, I would be at 88. And then 6 more puts me at the 82. So you can see that working. If I needed to go ahead and find a later term in the sequence, like maybe the 35th term or whatever, now I could go ahead and I could write that explicit formula. I have my starting value, my first term of 100. I know my common difference of negative 6. That gives me all the information I need to write an explicit formula for the nth term of the sequence had I needed some other term down the line over here. I don't in this case, so I'm not going to go ahead and do that. I've already done that in other examples.